Hello everyone, this is the video lecture for Calculus 2, section 7.7, approximation integration? Approximate integration? Approx integration. Anyways, we're going to be approximating integrals, and so what we're going to do is say, our integral is equal to, or at least kind of equal to, one of these formulas here. There, now it's more technically true. Anyways, so we got these three rules: midpoint rule, trapezoid rule, and Simpson's rule. And they have this distinct formula for each one of them. We have b minus a, it's my limits, divided by n, or 2n, or 3n, depending. And then we have our functions, our heights, being added up. And then you multiply it by this term in the middle, or I'm sorry, in the beginning, and then you're done. But see here, this average, these little averages on the inside, that's that midpoint that they're talking about. On trapezoid rule, we got a regular 1, and then a 2, 2, 2, 2, and it ends with a 1. Okay, I didn't write that. 1, 2, 2, 2, 2, 2, 1. And then Simpson's rule is 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, 1. So there's still a 1 at the end. Again, I didn't write it. But a 1 is always at the ends. And then here, you're always going to have a 4, 2, 4, 2, 4, 1. Okay. All right. So, ta-da, there you go. Let me draw some pictures. And this is just a formula for my x's, but whatever, I'll just show you what's going on there. What do these graphically represent? So let's just say I've got some kind of function going on here, and I want to find the integral underneath the area underneath the curve, the integral. And so midpoint rule is going to pick some points, like say right there, and I'm going to find the height at that midpoint. And I'm going to find the height at that midpoint. And I'm going to add those up, multiply by the width, and call it a day. So my midpoint, you can see I'm right there. I'm just trying to say, okay, well, here's the midpoint between some rectangles or whatever. So if I add up all of this area here, would it be equal to this? Yeah, maybe. I mean, you can see I got some extra added on, but I got a lot that I left out. And so it kind of equals out. Trapezoid rule is, I'm just going to do this here. Same kind of idea. I'm going to do 3 rectangles, though, because I think that's going to be better. Trapezoid rule is actually going to bring it up to that point and draw a straight line, trapezoid for each one of these. That's a straight line for each one of those. Basically, it looks like this, and a whole lot of those. You add those up, and you get an answer. Well, notice, again, we're really close now, right? We're not adding or subtracting a whole bunch of difference there. It's really close, but still not perfect. So Simpson's rule, what's the graphical representation for that? Well, it's kind of hard here in such a small little zone. But I'll try my hardest to show you. Basically, it's parabolas. We're doing little parabolas here for these guys. And so you could see that the parabola form will be closer tied to the actual curve itself. Okay, it's not just a straight line, it's more of like a curve. Well, that curve models our original curve better, okay? But those are just little tiny parabolas up there, okay? So now you know what the graphical representation is. Let's do a graphical representation problem. 77001. I got integral from 0 to 4 of f of x dx is equal to, and we're going to be solving for that in a few different ways. They have a graph here on the side, and it starts at 1. Let me try to get that a little bit better. There we go. And over here at 4, it ends at a height of 7. I'm going to try to make sure you can see all these. At 2, there's a height of 5. Okay, and then at 1, it actually has a height of 3.25. That's what I got. And then at 3, there's a height right here of 6.5. Again, I don't know if those are exact right here and here. you know, just matching them up. But that's what I was just looking at, and that's what I found, and that's what we're going to use for this problem, okay? So we're going to not get the exact perfect answer every time because it's not exactly perfect, but we're going to do the best we can. They're going to ask for left endpoints and right endpoints. And so these are two different shapes, two different ways of accomplishing our goals. Let's just say that I had just the two rectangles here. And so the left endpoints say that we're going to be using the point where it's colliding on the left side and going straight across. So that would be all this area, you add it up, and you get an answer. Is that a very good approximation? No, not even close. There's so much less than what we need. Okay, the other style is right endpoints. Right endpoints start over here and start with a right side. Oops. And then we go out over there. Notice again the height is determined by the right side, and then we just go straight across. So then we're going to add all these areas up here. Is that a pretty good approximation? Again, no, we're way overshooting it here. So we're going under here, we're going over there. So maybe if we combine the two and we see what's in the middle, just a thought there. So how do we actually find out what that would be for the left and the rights? So L2, 2 meaning there's only two rectangles, is that I'm going again from my 0 to 2, my 4 to 0, that's my interval, divided by 2, because there's two rectangles, times, and then the left endpoints here, if you go back to the picture, it starts right here at 1. I should have labeled that, I'm sorry, that's a 1. I start at 1 height. And then over here, we're going to start at the 5 height. See how we're just creating that right there? So 1 plus 5, so that's 2 times 6 is 12. For the right endpoints, again, we're going to start up here and go backwards in a way. So you can see the height here will be a 5, and the height over here will be a 7. Same kind of style, though. 4 minus 0 over 2, 5 plus 7. We got 12 times 2 is 24. Okay, now for the midpoint rule. This should be in between these two, right? So I got 4 minus 0 over 2 times. And so what are my midpoints for these two rectangles here? See, notice right here my midpoint would be at 1. So that would be my midpoint area. And then my midpoint for 3 is right here at the 6.5, all that area there. And so it's the same style, 3.25 now plus the 6.5. You add them all up, see what you get. And I got 19.5. Now what they got was 19.2 was the WebAssign answer. But this should still work because it has like a plus and minus answer. If it somehow says you're wrong and you put in this exact same thing, just send me a message and I'll see what's going on, okay? All right, cool. Last one they want is trapezoid. And so the trapezoid rule is interesting. We're going to do the same 4 minus 0 now divided by 2 times 2. And then we have, again, the 1 times my function height. I got a 2 times the function height. And then I got a 1 times the function height, and we're done. So I need to find out my heights, my 3 heights that I'm focused on. And so what are my 3 heights? I'm going to use a different color so you can see this a little bit better. I have these two rectangles, essentially, right? So my 3 heights would be at 1, 5, and 7. And then we're going to do a straight line across like that. So 1, 5, and 7. So 1, 5, and 7. Again, if we had more points in the middle, you just say 2 times this, 2 times that, 2, 2, 2, 2, 2, 2, 2. At the very end, a 1, and call it a day. So let's find out what this guy is going to be. A 4 divided by 4. 1 times 1 is 1. We got a 10, and we got a 7. Put it all together, and you get an 18 in the end. Again, that's going to be closer to the actual answer. And notice what's in between 24 and 12. I think it's 18. So, again, we're getting pretty close. So that's good. All right. Next question. 77003. It says integral from 0 to 1 of 5 cosine of x squared dx. Can you just find out what the answer is by integrating? Can I just integrate it and get an exact answer? No. You got an x squared on the inside. That is very difficult to solve. And so I'm going to say no. The reason why we're doing approximations here is because it's very difficult to do. They put n equals 4, meaning they want the 4 rectangles. So on your number line, we're starting at 0, we're going to 1, and they want 4 rectangles. So that would be, again, at half. Let me just actually write half. 1/4 and 3/4. So these are going to be my important numbers that I'll be using. Notice that we got 4 sections, correct? Well, how many numbers am I using? 1, 2, 3, 4, 5 numbers. So that's going to be important later as well. Later on, actually right here, right now, they're going to ask for a midpoint. So the midpoint for each of these, notice, is going to be 1/8, 3/8, 5/8, and 7/8. Do you ever do classes with on the ruler? Like, you ever have like a class back in high school where you had like the ruler and you would have to measure this and that? No, just me? Okay. Well, anyways, you start learning about eighths and fourths and stuff like that real quick. Like, who would have thought a whole class just on the ruler? So, midpoint rule. And so I've got 1 minus 0, my b minus a, and then I got divide by 4. And then I'm going to be multiplying it by all these different heights. So I got lots of heights going on here for my midpoint values, okay? So I need a lot of room to be able to do this. So I think I misdid it right there. I'm gonna start right here now. So here we go. I'll go ahead and do it. F of 1/8 plus f of 3/8 plus f of 5/8 plus f of 7/8. And what this actually makes is going to be a 5 cosine of 1/8 squared plus 5 cosine of 3/8 all squared plus 5 cosine 5/8 squared, and then finally 5 cosine 7/8 squared. Okay, there we go. Yeah, guess what? Calculator. So, yeah, I'm not going to sit here and try to do all that. It ends up being on the inside here, 18.178135. How many decimals do you go out? 6 is safe. 6 is safe. And if you did not get this, remember that we are going to be in radian mode. So make sure you're in radian mode when you're doing all this. Multiply by the 1/4, and you get your answer, 4.544533954. I don't know how many decimals they want, but we can give it to them because we were being exact the entire way, right? No rounding. All right, and now finally the trapezoid rule. So same kind of deal. We got 0 to 1. Now we got 2 times 4 in the bottom, and then multiply by all my stuff. Now, remember that we had 5 original points that we're going to be using. Those are the points we're going to use now. Here we go. F of 0, 2 times f of 1/4. Let me make that look a little bit better. 2 times f of 1/2. 2 times f of 3/4. And then we got finally f of 1. Whew, man. Lots going on there. So just like last time, let me just, I guess, demonstrate what's going on here. I've got cosine of 5 cosine of 0 squared plus 2 times 5 cosine of 1/4 all squared plus ... Remember, it's again 2, 2, 2, 2, ending with a 1. And calculator, I got 1/8 in the front times 35.83035585. And I do that, my final answer is a 4.47879. 4481. Wow. Now, are those similar? 4.5, 4.5, yeah. Sorry. I would say that this is probably the more accurate one. And so, here I have a note in my notes. That's always handy. Wow, that takes forever and is prone to error. Let's use Excel instead. I don't have Excel. What I have here is Libre Calc, and that's a free version, I guess you can say. I don't have Excel on my computer. That's just what it is. But obviously it looks like Excel. It functions like Excel, especially for what we're going to be doing here today. So I'll be using this here in just a little bit to show you how to get these done much faster. Okay, so that's cool. Let's go on to our next problem, 77014. So I got integral from 2 to 3 of 1 over the ln of t dt. They say, and they don't know what that is. We want to find it. They say n is equal to 10, and they want trapezoid, Simpson's rule, midpoint, all that stuff. And notice n equals 10, so that would be 11 different numbers that I'm going to have to type in for each one of those, and it takes forever, and it's long. We want to do Excel. That's my point. We want to do Excel. So let me get us started with what midpoint rule would look like at least. I got 3 minus 2 divided by 10, and then I've got 1 over ln of the, again, think of it, I got a number line from 2 to 3. I'm cutting it up into 10 different numbers, and then I want the halfway point for the first two, and that's going to be actually 0.5, because it would be 2.0, 2.1, 2.2, 2.3. Well, then the middle between 2.0 and 2.1 is 2.05, then plus 1 over the ln of 2.15. Again, between 2.1 and 2.2 is 2.15, blah, 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 and it takes forever. And no, I don't want to do that in my calculator. I wanted to use Excel. So I'm going to give you a written version here, and then I'm going to actually do it. So I'm going to say this is Excel. And so I have my A column. I'm going to put 2.05 in the very first entry. Enter. And then I'm going to say the next one, the next row I'm going to say is A1 plus 0.1. Enter. And then I'm going to click drag it down. For column B, I'm going to start with an equals 1 divided by ln of A1. Enter, and then click drag it down. At the very bottom of my list that I'm looking for, I'm going to say equals 3 minus 2 divided by 10 times the sum of B1 colon B, I think it's 10 is where we're going to end. And then it gives you your answer, which would be 1.118107. So what I want to do is I want to show you that right quick. Then we're going to do the trapezoid rule and the Simpsons rule and all that kind of stuff. This is, I guess you can say, like a prototype of what you're going to be doing for any of the other problems in this section. So here we go. Start off, I want to type in here the 2.05. And sorry if it's not super clear. It's just the best we got, I guess. Actually, can I zoom in a little bit? No, I don't want to zoom in too much here. There, that's going to be good enough. Okay, enter. So I actually typed the number, enter, and then I say equal sign, and it's going to be A1 plus 0.1, enter, and notice it automatically computed that for me. And I'm going to click drag it down, I think until 10. Yes, because see how you got the 3.05 there? You don't want that. That's outside of our domain, I guess you can say. Over here in B, I'm going to say equals 1 divided by ln of A1. And then I hit enter, I click drag it down. And so these are all my heights. And so what I want to do now is I want to say down here, or anywhere really, equals, and then this is my formula for the answer, 3 minus 2 divided by 10 times the sum of B1 to B10. Notice the colon in between gives it the, like, from this to that. And there's my answer, just like I had said. That's your answer for WebAssign. You type that in and you're done. Okay, cool. Now, let's go back, and I'm going to do the trapezoid rule. I want to show you what it looks like in normal whatevers, and then we're going to actually do the real math here in a second, okay? So now I have 2 times the 10, and I'm going to be using the actual values, so ln of 2, and then 2 times 1 over ln of 2.1 plus 2 times 1 over ln of 2.2 plus ... forever. And yeah, it takes forever. There's a whole lot going on. So I'm going to write out what I'm going to do in Excel, and then I'm going to actually do it. So I've got a is equal to cats. A equals 2, A1, sorry, and then you hit 2, enter. And then I'm going to say A1 plus 0.1, enter, and drag down. B. So then I've got 1, and I hit enter. And then 2 equals 2, equals 2. And then I hit enter, and I drag it down, not exactly to the end. And then at the very end, I'm going to type a 1 and hit enter. This is going to be my 1, 2, 2, 2, 2, 2, 2, 2, 2, 1 multipliers. In column C, I want to say 1 divided by the ln of A1, and then hit enter, click, and drag it down. At the very bottom, somewhere down here, I'm going to say 3 minus 2 divided by, open, 2 times the 10, close, times, and this is where it's a little different, sum product of, and this is going to be B1 to B11 is actually where we have to start or stop. If you remember, I have 10 sections, therefore 11 numbers, and then a comma, move this over, C1 to C11, enter. And I get a result of 1.119061. Okay, so let's go and accomplish that here in Excel land. I'm just going to delete everything that I already have. You can go and use different places, different numbers. I just want to keep it simple for you right now without making it too complicated. So 2, enter, and then equals A1 plus 0.1, enter, and I'm going to drag it down until I see the 3, which is right there. Over here in B column, this is going to be my multiplier, so a 1, and then you can just do 2's all the way down, and then a 1, right? So that's totally easy to do. But, you know, what if we're just trying to make this a little bit better? You could say equals 2, and then you can drag that down. I don't know. I don't like doing this, but maybe you do. But not to the last one. The last one's always a 1, so make sure you put a 1 in there. Anyways, so you got your multipliers, and then we got our 1 divided by ln of A1. Click, drag it down. Anywhere, doesn't matter, equals the 3 minus 2 divided by 2 times the 10 times the sum product of B1 to B11, comma, C1 to C11, close. And there's my answer again. It should be basically right on what the others have been so far because we're trying to be very accurate. We're using 10 rectangles. That's pretty good. And here's 10 trapezoids. Okay, last one, the Simpsons rule. So again, I'm trying to give you a very detailed version of how to make this happen for all of your problems, not just this one. So 3 minus 2, 3 times the 10, and then times, and now we got 1 over the ln of 2. You got a 4 times 1 over ln of 2.1. And you got a 2 times 1 over ln of 2.2. And then you have a 4 times 1 over ln of 2.3. 4, 2, 4, 2, 4, 2, 4, 2, 4. Then a 1, and then you're done. So now let's accomplish that in Excel. So 2, enter, and then you're going to say A1 plus the 0.1, enter, click and drag it down. My B, I actually do it manually, just like you saw that one other time I did. So 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, something like that, and then a 1. Okay, it's probably pretty close. And then C, I'm going to have, again, that 1 divided by ln of the A1. Click, drag it down. And somewhere down here, anywhere doesn't really matter. 3 minus 2 divided by 3 times the 10, and then times the sum product of B1 to B11, comma, C1 to C11. I got an answer of 1.118428. And let's see if we can do that now in Excel. So here we go. Delete everything, I guess. You could totally not delete everything and it'll be totally fine. I've seen some people start with like a template, and you basically just put the new function in. You don't have to retype everything every time. I'm not doing that. I think this is fairly simple to do. See, I went over. Okay, there we go. And then I got my 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, and then a 1. And then finally over here we got ln of A1. Click, drag it down. Last part is going to be that 3 minus 2 divided by 3 times the 10 times the sum product of B1, B11, comma, C1 to C11, close. I got something wrong. Sum product, yep, B1, B11, C1, C11. 3 minus 2, 3 times 10. Uh-oh. So, did I mess up somewhere? ln of A1? Yes. I feel like I mistyped something. 4, 2, 4, 2, 4, 2, 4, 2, 4, 1. Yeah, that's fine there, too. That's odd. I mean, I'm looking right at my formula here, and surely I just mistyped something. Well, here's the thing. I know that it's wrong because obviously I typed it into WebAssign. It says I'm wrong. Let's just start over. That's okay. I mean, I don't mind. I'm not going anywhere. Are you going somewhere? So A1 plus 0.1. Maybe I messed up. Maybe I over-calculated something. I don't know. So 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, and then a 1. And then this is equal to ln of A1. And anywhere, doesn't really matter, equals 3 minus 2 times, and it's a 3 times 10. Yeah. Oh, hold on. That's a divide right there. And then times sign, sum product of B1 to B11, C1 to C11. And I got the same answer. That's so weird. Did I just mistype my answer in my notes, maybe? I don't know. 4, 2, 4, 2, 4, 2, 4, 2. It makes me wonder. Here, hold on real quick. I know this is being recorded. What if I change these all to 2s? Do I get my original? So I feel like there's something amiss. ln? Was it 1 over ln? Right? And so why am I getting a different answer all of a sudden right here? 0.1, 2s. Like, you saw that I got the 1.119 whatever last time. So why is it being all tricky and difficult today here? I do not know. Will it undo everything? Let's go back and look at what we had. Okay. Can I redo? Is there a redo? Redo. That's weird. Huh. Okay, well, I don't know why, oh, those are the 4 2s. Hold on. Okay, that was my trapezoid rule, right? See, with all the 2s in there? So, basically, the only difference should be a 4, 4, 4, 4, and a 4. And so, I'm now getting a different number even there than what I was expecting. These are the LNs. Oh, and this should be a 3. That needs to be a 3. There we go. I do not know why the other one was not working. I mistyped something twice. I don't know what it was, honestly. But that's okay. I mean, that's part of the recording, I guess. It's like, hey, what if I have a problem? What is it going to look like? Well, there, I had a problem. I don't know what it was. I went back. I changed my, remember I had a lot of 2s right here? Remember that? I had a lot of 2s. I just changed them to 4, 2, 4, 2, 4, 2, 4. And then I just changed that number right here from a 2 to a 3, and it works. Okay, so that's all you're really doing here. I don't know what I could have done wrong. So, I don't know. But there we go. We got the number that I was expecting. And now you know, nothing's perfect. We just try to get by and do the best we can. So, all right. We did Excel. Cool. Now we're going to move on. There's non-Excel stuff as well in this section. And so they're wanting to know the errors of things. I gotta say, this is one of my more least favorite things to do, but it's okay because guess what? I'm teaching it, so here we go. They say trapezoid rule with using 8 gave me 11.730327, and my midpoint rule using 8 rectangles was 11.773059. And, this is what I got from Excel. Okay, they didn't give that to you. I'm looking here like, what's going on there? I used Excel. I got this thing. There's nothing different than what we've just done, okay? So 0 to 1, 8 of them. So we're going to get a lot of 8s and stuff and whatever. Okay, so that's my part A. Cool, moving on. Part B now says, find the error for the trapezoid rule. And there's a formula for this. The error of trapezoid rule, absolute value is less than or equal to this K, capital K, times B minus A cubed all over 12n squared. Okay. There's a similar formula for the error of midpoint rule, K B minus A cubed all over 24n squared. Now, B minus A is obvious, N is given to us, it's 8 or whatever. And so, what is this K? So that we have, I'm going to show you now, our absolute value of the second derivative is less than or equal to K for all A less than or equal to X less than or equal to B. And so, what is that? And maybe I didn't draw it super well, especially since it's probably your first time seeing it. It's just an upside down A. That's all it is. So, whenever you see an upside down A, that means for all. Okay, if you see a backwards E, that means each, I guess you can say. Or, no, exists. Exists. The vertical line just straight up, like, you don't have that here. It means such that. There's all these cool little symbols, like here. You've probably seen that one. Those are the real numbers, as in like decimals and stuff like that. So there's all these cool little symbols that you'll be learning a lot more later, but I'm saying for all. So what does this whole thing mean right here anyways? K is your maximum of the F double prime, is the max F prime. And it has to be within the original domain, okay? In order to do any of this, we need to find our second derivative. So let's do that. My original here, if you go way back up to the original, right there, is 13 cosine of x squared. So then my first derivative would be 13. My cosine turns into a negative sign. Leave the inside alone. Chain rule, take the derivative of the inside to get a 2x. Okay. I'm going to clean that up a little bit. And so I got negative 26x times sine of x squared. And so that I could do my second derivative now would be product rule. So now take the derivative of the first, negative 26, and then I leave the second alone. And then plus, and then I got my negative 26x original, and then derivative of sine is going to go to cosine. leave the inside alone. Chain rule says you got a 2x on the outside there. Wow. So I'm supposed to use this function and find the maximum value from 0 to 1. So what's the max height from 0 to 1? And this is actually kind of sad because often we have to use 0, I don't know, 0.1, 0.2, 0.3. We got an infinite number of things. You can use 0.3333333, 0.5, 7071. There's all kinds of different decimals between 0 and 1. I'm trying to find the maximum height. Well, honestly, the best way to do this with any of these problems that you're going to be doing in this section in this class is that you're going to be plugging in the originals, 0 and 1, and you're going to just see what you get. So you plug in a 0 into all this stuff right here, so f double prime at 0, and I got 0. That doesn't sound like a maximum to me. So then I plug in a 1, and I get something weird. That's actually what my notes say. It says something weird. Wow. I'm just going to put weird. Okay. Okay. So these are actually not going to be super helpful to you because I got something weird apparently, and that's not what I'm looking for. Their answer is k is equal to 78, and they say, yay, you know that, right? So what we're going to do is I'm just going to do a little bit of analysis. This is great for most of the questions. Okay, plug in the endpoint, see if it works. But when that fails, and you'll know when it fails, you'll just know it. We're going to have to do something else here. I'm going to try to see these individually as, I guess, whatever their range could be. Range, so the y values. Each individual piece. So like this sign here of x squared, I don't really care about the x squared so much. I care about the sign. And sign could be anywhere from -1 to 1. Okay, that's its range, its y values. Notice this little x right here. That little x can go from 0 to 1. Okay, because again, that's what x goes to. We got my cosine. Again, I don't care about that. It's going from -1 to 1. But not at the same time as sine. So that's going to be a little weird. And then finally right here, that's going to go from 0 to 1 as well. If I take a 1 and I plug in a 1 here and a 1 there, I feel like I'm maximizing the whole thing, but I'd have to plug in a 1 right here as well. That's when I got that weird stuff. Cosine at 1 is not an easy number. What they eventually do is they just say, you know what? We're just going to do the best we can and say, pick the biggest numbers. I'm not kidding you. +1, +1, +1, +1. Don't necessarily agree with all this, but that's okay. Here we go. -26 times a 1. And I got a -26 times a 1 times a 1. This whole thing right here is a 1. And then times 2 times 1. Yep, that's what it is. And they want the absolute value of this thing, and it actually does end up being absolute value of -78, which is 78, which is your k, which they're wanting to use. Now, we're not done yet. Now I can go back and actually start solving for this stuff. ET, absolute value, is less than or equal to the 78. 1 minus 0 cubed, all divided by 12 times the 8 squared. Cool. You just put in a calculator, and I got 0.1015625. Awesome. Same thing with my EM. Same style, plug in. That's just a 24 now. So basically, you just cut it in half. 0.50788125. Okay, great. I used red. Part C, because we're not done yet. Isn't that so cool? It says, how large does n have to be within 0.0001 of the answer? Now that is a strange question here. We're going to do this for both of them, apparently. So my error for trapezoid rule, if you go back to the formula, is k times b minus a cubed over 12n squared. And I'm replacing my error now with the point 001. I know that k is equal to 78. I know b minus 1, b minus a is 1 to 0 is 1. 12, and then n is now what we're going to solve. We're going to solve for this n right now. Oh, so what I'm going to do is actually multiply all this to the other side, and I get 0012n squared is greater than or equal to, wait, what? And then 1 cubed is 1 times the 78 is just going to be a 78. So, why did the alligators change? Why did the alligators change? Let's do a little problem over here, and I have not tried this ever in my life, but maybe it'll work. So I've got 3, and let's do a fraction, something kind of easy here. No, how about this? I got something better. 2 is less than or equal to 9 over 3. Okay? So isn't this result here 3? So it would be bigger, right? And apparently I am not doing that right. Forget what I was doing there. The decimals move around and you change the alligator sign, and there you go. Okay, great. So, whatever. Forget what I was doing there. That's why I didn't ever do it, because it's probably not going to work in what I was wanting to do. Moving on. Basically, when you move something over, you change your alligator in this problem. There's a lot more to it, but I'm not going to go into it. N squared, I'm going to divide this to the other side, makes this now greater than or equal to the 65000. So I divide it to the other side, and then I square root both sides, and so we got n now is greater than or equal to 254.95, blah, 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 blah. And so you want n is equal to 2, well, greater than or equal to 255. There you go. I'm just going to tell you how to do it. This is how you're doing it, and you move on. And you can see why I don't really like this stuff that very much. It's just a lot of tediousness, and that's okay. We can have personal preferences, and we will make it through it together. 24, again, n squared, I don't know what that is. Multiply it over, and so then you flip your sign. 0024 n squared greater than or equal to 78. Divide to the other side. N squared is greater than or equal to the 32500. Square root both sides. N greater than or equal to 180.2775. And so n is going to be greater than or equal to 181. Again, we have to have a whole number. Turn the page. Apparently, I have a whole other problem like this. Oh, my goodness. We got this, guys. Last problem. Last one, okay? Here we go. Integral 0 to 1 of 5e to the x squared dx. They don't know what n is, but they know that my error is less than or equal to 0.0001. Okay. Yes. Maybe I flipped my alligator earlier. I don't know. I know you flipped the alligator. Maybe it's just because I was thinking of the 0.11 is going to be less than that much. My error is less than, so I want that. I don't know. Blah, blah, blah. We're going to flip the alligator. I just know that whenever you divide by something, it flips alligators, but maybe I was just doing it wrong. Oh, maybe it's a negative. I don't know. Moving on. E for Simpsons. Here's a new formula for you now. K times b minus a to the 5th power, and then divided by 180 n to the 4th power. And in this case, k is the maximum of, you ready for this? Your 4th derivative. Okay, so we had to stop doing Newtonian notation because it just gets unwieldy. And we put a 4 up there and call it a day. It's still kind of Newtonian, I suppose. I don't know. So we need to take our fourth derivative, find the maximum, and then we plug it in, and then we go and plug it in and plug it in. Plug it in, plug it in. F was originally equal to this guy, 5e to the x squared. My first derivative. The derivative of the x squared comes down, leaving it with us with a 10x e to the x squared. My second derivative comes down, making a 20x squared e to the x squared. My third derivative now. Oh, wait. This is product rule. And so I took my derivative of the second one, but I left the first one alone. Now I take the derivative of the first one, leaving just a 10, and I leave the second one alone. Oh, yes. Now we just got the third derivative, and then we got the fourth derivative. Whew. Taking the derivative same way here. I'm going to bring down that derivative here in the front, making a 40x cubed e to the x squared. I'm now going to take this as product rule and say now derivative of this guy will make my 40x e to the x squared. And then I got this guy here, derivative again comes down, 20x e to the x squared. Fourth derivative. Is it okay if I just copy? So 80 x to the fourth e x squared plus 120 x squared e to the x squared plus 80 x squared e to the x squared plus 40 e to the x squared plus 40 x squared e to the x squared plus 20 e to the x squared. And some of that will combine. It says, hey, where's the maximum given our original domain? Remember, it's 0 to 1. This thing grows. It does this. So we got 0. We got 1. Where do you think the maximum value is going to be? Probably at 1. And so what I'm going to say is x equals 1. Plug it in all of this stuff here. And so fourth derivative at 1 is equal to 380 e to the 1, which is my k. Oh my goodness. Now we can go back to that formula. ES less than or equal to k b minus a to the fifth. 180 n to the fourth. Okay, so my error was 0001. So this small number is going to be less than or equal to this stuff here? Or is this stuff here supposed to be less than that? See, what I'm thinking is that it's actually starting like that because I already have a value for my error. I can't remember. I don't know. Just this is how it's looking to look in the end. I know you're probably thinking, gosh, man, it just doesn't matter. Just do it. I know, but I'm the teacher and I'm a math guy. I'm supposed to be able to know everything like that, right? So 180 n to the fourth. Multiply the other side, divide by my numbers and all that stuff. So 0.018 n to the fourth, 380 e to the 1. Again, that's just a 1 there, thankfully. Divide to the other side, n to the fourth is now 1900000, all divided by 9, e to the 1. And then I'm going to fourth root both sides. Super awesome. And so I actually get, eventually, 15.4775. And so my n has got to be greater than or equal to 16. I have one last piece of note here. It says, the rest are repeats, use Excel. We did it. We're done with that section. Thank you very much. Have a great day.